Hi class, welcome to How To Video 5. In this video, I'm going to show you how to calculate the mean difference between two independent samples or groups. I'm also going to show you how to choose the appropriate independent samples t-test to determine if that mean difference is statistically significant. I'll show you how to perform that t-test. I'll also show you how to calculate the effect size. And the effect size is used to determine the magnitude of the difference between the groups. And then finally, I'll show you how to create a bar graph in order to showcase the means and standard deviations of both groups that are being tested. Now today in this video, the data we're going to be looking at is body mass index. It can be abbreviated BMI, and perhaps you've heard of BMI before. It's a very simple measure of body fat. Lots of studies, lots of research has used BMI in order to assess body fat in the past. I said earlier it's a simple measure, and that's true. To calculate BMI, all you need to know is body mass in kilograms and a person's height in meters. And once you have those two, body mass and height, which are easy to assess, you can calculate BMI. Now the specific equation for BMI is body mass, like I said, divided by a person's height in meters squared. And again, that's the data that we're going to be looking at here today in this how-to video. It's also the data that you're going to be using to answer questions for your assignment number 5. Now the data that I'm going to be using, just like in previous videos, will be different than the data that you have for your assignment 5. My data will be BMI data, but it'll be in middle-aged adults. Your data will be BMI data in older adults. Now, independent samples t-test, if you refer to the PowerPoint, it goes into great detail on this. Independent samples t-tests are used to compare the mean difference between two independent groups, between two independent samples. And so, like I said earlier, the data that you're going to be looking at is in older adults. The data that I'm going to be looking at in this video is in middle-aged adults. One of the things in a recent study actually just came out a couple years ago, BMI, like I said earlier, is an assessment of body fat. Again, it's a simple assessment. It's not the best assessment, okay? I would say it's a crude assessment of body fat, but it is simple. And that's why a lot of, like I said earlier, a lot of research studies use it. When you see on maybe the news, they talk about obesity. As you probably are aware, obesity is a major public health concern, especially here in the United States. When you see those news reports and they refer to studies, yeah, oftentimes the way that the news reports obesity is by BMI. Okay, they use BMI in order to determine whether or not someone is obese. And again, with BMI, the higher the BMI, the more body fat. The lower the BMI, the less body fat. Okay, so again, it's a very simple scale. It's a very simple measurement. Okay, so again, that's just a little background on BMI. Going back to what I was saying earlier, there was a recent research study that suggested that BMI can also be used to assess someone's overall health and functional ability. And so we're going to actually put that to the test today in this video and with your assignment 5. What we've done, and I'll show you in just a second, is we've divided our group up. So in this video, middle-aged adults, that's the data I'm going to be looking at. We've divided these middle-aged adults up based upon their functional ability. And so we've classified half of the middle-aged adults as high functioning, and we've classified the other half of the middle-aged adults as low functioning. And you'll notice that's the same thing that's been done in your assignment 5 with your older adults. Half of the older adults are high functioning, half of the older adults are low functioning. Now you might ask, well, how do you do that? How do you assess someone's functional ability? And there's lots of research on this as well. One of the most common things to assess functional ability is called a short performance battery test. And that test consists of balance, it consists of walking speed, and it consists of one's ability to stand up independently from a chair. And so imagine, in order to assess someone's functional ability, a researcher has to perform all of those tests on that person. And then after they perform those tests, they evaluate how that person does on those tests, and then they're able to classify them as being either high functioning or low functioning. And so that's what's being done here in the data that we're going to be working with today and the data that you have in your assignment. So imagine before the study even starts, we've already done this. We've already done this functional battery test and have classified our adults as high functioning or low functioning. And kind of the objective of this is we're going to see if BMI, okay, that's what we're testing today with the independent samples t-test. We're going to see if BMI, the mean difference in BMI between the two groups, between the high and the low functioning groups, we're going to see if it's statistically significant. And if it is significantly different, again, implications. I talked about that, I believe, in the last how-to video with correlations. That's always a good question to ask, you know, what are the implications of the results? What are the implications of what we're trying to do with this independent study, what we're trying to do when we compare two independent samples? Well, one of the benefits of doing an independent samples t-test is if we do find statistical significance, let's say we find that BMI is significantly different between the two groups, then afterwards, this provides support, this provides evidence that maybe we can use BMI in the future in order to classify adults as either high or low functioning. Now think about that for a second. Think about what I've told you thus far. BMI is a very, very simple measure. All you need to know is height and weight. Once you have that, and once you've converted it in the correct units, you can calculate BMI. It's easy. Think about how you assess functional ability, doing that battery of tests, doing a balance test, doing a walking speed test, doing a chair rise test. Which one sounds easier to do? Yeah, BMI, okay? BMI is definitely the easier measure as opposed to doing all those tests to assess functional ability. So think about that. If we find a statistically significant difference between groups for BMI, maybe in the future, instead of having to do all of those tests, instead of having to do that entire battery of performance tests, we could just do a simple measure of BMI, and that may be good enough in order to classify someone as either high or low functioning. And so, wow, yeah, wouldn't that be great? Wouldn't that be great for doctors, physical therapists, occupational therapists, people working with middle-aged and older adults? Instead of having to do a whole battery of tests and take up a lot of time, just do a simple BMI measure, and based on that BMI, we can classify adults as high or low functioning. And so hopefully that makes sense. Hopefully you can kind of understand, oh, okay, I kind of see what we're doing here. I see the implications. I see, you know, the importance of doing an independent samples t-test like we're going to be doing here today. Again, by doing independent samples t-test, and if we do find a significant difference, perhaps we can use that dependent variable like BMI in order to identify, okay, or classify adults, like in this example, as high or low functioning. Okay, so that was just a little background on BMI, on functional ability, and the data that we're going to be looking at here today. So let's go ahead and take a look at the assignment. And just like in previous videos, I've broken it up to where over here on the right side, we have our assignment 5 Word document. And then on the left side, we have a blank Excel spreadsheet. And I've got them side by side, that way we can look at them simultaneously. If you take a look at the Word document over here, make sure before you start, just like always, don't forget, write your name in the top left corner of the page. It says here at the top, suppose we want to compare body mass index, or BMI, between a group of high and low functioning middle-aged adults. Again, remember, the data I'm looking at today is in middle-aged adults. It is different than the data that you have for your assignment 5. For your assignment 5, it's looking at similar type data. It's BMI, it's in high and low functioning groups, but your data is going to be in older adults. Below are the results. Copy and paste these data into an Excel spreadsheet and use these data to answer the following questions. Okay, so let's go ahead and do that. Let's go ahead and copy and paste our data over here into our Excel spreadsheet. And you can, again, do this exact same thing with your data. And just remember, just like in previous how-to videos, I'm going to be working, with my data here, but again, I'm going to be solving problems that are identical to the problems that you have on your assignment 5. Okay, now again, because I have different data than you, right, my answers could be slightly different than yours. So again, keep that in mind. But again, the process that I show you today, again, the process is going to be the same that you're going to do, okay, when you do your assignment 5. Again, your data is going to be different, your answers may be different, but the overall process that you're going to be doing will be the same. Okay, so now that we have our data copied and pasted into our Excel worksheet here, let's go ahead and scroll down to question number 1. What are the means and standard deviations for BMI in the high and low functioning groups? Report them as mean plus or minus standard deviation. Okay, so very similar to the previous how-to video, we're going to calculate the mean plus or minus standard deviation and report those here for question 1. What I'm going to do, I'm going to write in over here. I know in previous videos, I think the video for the last video, the last how-to video, I reported the means and standard deviations and all of our statistics down below the data. Today, just for simplistic sake, it works a little bit better when we do these independent samples t-tests if we report the statistics to the right of the data. And so that's what I'm going to do here, and you can do the same thing with yours. And so I'm going to write in all of our statistics now over here to the right side of the data. So mean standard deviation, that's what question number 1 asks us to calculate. And then also too, it asks us to calculate for both groups. And so again, if you look at the data over here in the document, if you look at the data over here in the Excel spreadsheet, yeah, you can see, okay, which of our subjects are high functioning. It looks like the first 10 subjects are high functioning, okay, a part of that high functioning group. And then the last 10, okay, subjects 11 through 20, they're considered the low functioning group, okay. They have low functional ability, they're the low functioning group. And then, yeah, here their BMI scores over here. So what we need to do, we need to calculate the mean and standard deviation for BMI for both groups. So to do that, I'm going to put high functioning okay up here at the top, and then right next to it I'm going to put low functioning. Okay, and then yeah, we can bold it too, just to make sure it's a little bit easier to see. Okay, so let's go ahead and calculate the mean and standard deviation for the high functioning group, which will be in this column. Again, by doing what we've done and making these labels here, basically we're saying that again the mean and standard deviation for the high functioning group will be here, and then the mean and standard deviation for the low functioning group we'll put right here. So let's do the high functioning first. So click on your open cell next to mean. Let's do the mean. Again, similar to how we've done in previous videos, calculating the mean. Go to average and then click and highlight the BMI scores only for the high functioning group. So I'm going to start out with subject number 1 and go down to subject number 10, which is the last high functioning subject. Once I've highlighted the subjects in the high functioning group, then I'll click OK. Alright, and so there's my mean right there in my high functioning group. Again, if you need to adjust, looks like it's already adjusted for me. If you take a look back at the Word document, it says round these values to the second decimal place. Looks like mine's already rounded to the second decimal place, but remember to do that. You can adjust the mean, the number of decimal points here at the top. And so, yeah, so it looks like it's already good to go. We've already got it rounded to the first 2 decimal places. Again, decimal places being to the right of the decimal place 1, 2. Let's calculate the standard deviation next. Again, go to the standard deviation function, STDEV, click OK. And then again, same thing, click and highlight the BMI scores only for the high functioning group. And then click OK. All right, there's our standard deviation. Again, just like with the mean, let's round it to the first 2 decimal spots. So there we go. Again, 2 decimal spots to the right of the decimal, 1, 2. Okay, we get a standard deviation of 1.37. Let's do the same thing for the low functioning. Let's calculate the mean, average. Now we're going to highlight only the subjects in the low functioning group. Okay, so starting here with subject 11 and then going down to subject 20. Okay, and then click OK. All right, get a mean of 24.89. Let's do the standard deviation next. Okay, highlight again the subjects in the low functioning group, starting with subject 11 to 20. Once we've done that, click OK. And then there we go. We've got our mean and standard deviation there for the low functioning group. Again, let's adjust the standard deviation to where it's rounded to the first 2 decimal spots. And again, you can use that function that I just used up here in order to increase or decrease the decimal. In this case, I needed to decrease the decimal to get it to the first 2 decimal spots. Again, 1, 2 to the right of the decimal. We get a standard deviation of 3.16. Okay, now that we've got our means and standard deviations for both groups, let's now go and report these in our Assignment 5 Word document. So it says report them as mean plus or minus standard deviations similar to the previous how-to video. Let's do that. So the mean for the high functioning group was 23.74. And then we can do the plus or minus sign. Again, if you want to get the plus or minus sign, you can just take it from here. You can just copy it and then paste it right here. Bold it if you need to. And then plus or minus the standard deviation. The standard deviation for the high functioning group was 1.37. And then again, it's always good to report the units for the variable we're measuring. Again, the variable we're measuring, the dependent variable, is BMI. BMI is measured in kilograms per meter squared. So to put the units, you can just simply copy and then paste just like I've done here. Just like that, and then yeah, you can bold it. Cool. Okay, let's do the same thing. Low functioning, let's report the mean plus or minus standard deviation. The low functioning mean was 24.89. Plus or minus standard deviation 3.16. Now I'll just copy and paste the units there, kilograms per meter squared. All right, cool. So now we've got the mean plus or minus standard deviation reported for BMI for both groups, the high functioning and low functioning groups. Okay, let's go to the next question. It says calculate the mean difference. Calculate the mean difference between the high and low functioning groups. Okay, so that's very, very easy to do. The mean difference, all we have to do is just take the mean of group 1 minus the mean of group 2. So very, very simple to do. So to do this, again, we can do it right over here in Excel, okay, and then put our answer back over here to our assignment, but let's do that in Excel first. So I'm going to type in my next statistic here that we need to calculate for question 2, the mean difference. That's what it asks us to do. Okay, again, I'll bold it. And again, like I said, the mean difference, all it is just group 1 mean minus group 2 mean. That's all it is. So to do that, click on your empty cell next to the mean difference like I'm doing. Click equals on your keyboard. Go to the mean for group 1, which we just calculated as 23.74. You can click on that cell with that mean and then hit minus. And then click on the cell with the other mean, okay, the group 2 mean, the low functioning group in this case, which is 24.89. And then now that we've done that, again, basically what we've done, again, is this mean here, okay, in this cell, minus this mean here in this cell, group 1 minus group 2. Again, in this case, it's the high functioning group minus the low functioning group. Once we've done that, then click enter on your keyboard, and that should calculate the mean difference. Okay, we get a mean difference of negative 1.15. Now, why is it negative in this case? Well, it's negative because if you take a look, group 1 in this case is less than group 2, right? Group 2 has a higher BMI, a mean BMI, than group 1 does. And so when we go a smaller value minus a larger value, yeah, we're going to get a negative value. Okay, so again, when we calculate the mean difference, it's okay. It's okay if we get a negative value. It's okay if we get a positive value. Okay, all that means, negative or positive, just means, again, the size of the means. Okay, if the mean of group 1 is less than the mean of group 2 and we subtract, then we're going to get a negative. If the mean of group 1 is larger than group 2 and we subtract, we'll get a positive. And so again, that's all that means. Okay, that's all that means for the positive and negative sign for the mean difference. Okay, so we calculated our mean difference as negative 1.15. That's what we're going to report down here in our assignment 5 for question 2. So negative 1.15, and again, it's always good to put the units. So again, you can copy it from up here. Okay, so the difference in BMI between the two groups is negative 1.15 kilograms per meter squared. Okay, cool. So now we've calculated the mean difference. Let's move on to the next question. Question 3. Based on the standard deviation for the high and low functioning groups, we can assume the variance is, and then we've got options here. So this is a multiple choice question, as you can see. Is the variance equal? Is it unequal? Okay, or is it the latter? The variance cannot be determined for the standard deviation or none of the above. Well, again, if you refer to the PowerPoint, it goes into great detail on this. Really, our answers are we can really break it down. It's going to be one of these two here. Again, yeah, we can use standard deviation to determine variance. If you remember, if you refer back to a previous PowerPoint, one of the primary measures of variability is standard deviation. So yeah, obviously we can use standard deviation to determine the variance or variability. And so that's what we're going to do here. And if again, it goes into great detail in this in the PowerPoint. So for more detail, again, I encourage you to take a look at the PowerPoint on this. But what we're going to do basically here to determine whether the variance is equal or unequal, we're going to compare the standard deviations between the high and low functioning groups. So again, that's what this question is asking. It's asking, is the variance equal between the high and low functioning groups? And then to determine that, we can compare the standard deviations. So that's what we're going to do. So back over here in our Excel sheet, I'm going to add another statistic. This is what we're going to calculate to answer question 3. I'm going to call this standard deviation comparison. Okay, because that's essentially what we're doing here. We're going to be comparing the standard deviations between the two groups. Now, to compare the standard deviations between the two groups, it talks about this in the PowerPoint. What we're going to do is we're going to take the higher standard deviation of the two groups. Now, if you take a look at our two groups in this example, which group has the higher standard deviation, the high functioning group or the low functioning group? Yeah, in this particular example here. Now, again, it may be different for your data, okay? So remember, keep that in mind. Your data may be different than mine, but for my data here in this video, the standard deviation for the low functioning group is higher than the standard deviation for the high functioning group. The low functioning group has a standard deviation of 3.16. That is higher than 1.37. So what I'm going to do to make this comparison between the two standard deviations, I'm going to take the higher standard deviation. So in this case, the higher standard deviation is for the low functioning group here, 3.16. I'm going to highlight this empty cell. I'm going to click equals on my keyboard, and then I'm going to click on this cell with the higher standard deviation, in this case 3.16. And then I'm going to divide, okay, by the cell with the lower standard deviation, okay, the group with the lower standard deviation, in this case the high functioning group. Here's the cell with their standard deviation, in this case 1.37. So to compare standard deviations, again, it talks about this in the PowerPoint. Please refer to the PowerPoint for more details. To compare standard deviations, all you have to do is take the higher standard deviation, okay, whether that's in group 1 or group 2. In this case, it was in group 1, or excuse me, group 2. Group 2 had the higher standard deviation, 3.16. Take that standard deviation and then divide it by the smaller standard deviation, okay, and in this case, group 1 had the smaller deviation. The higher functioning group had a standard deviation of 1.37. So the larger standard deviation divided by the smaller standard deviation. Once we've done that, click enter. and that should calculate, okay, our standard deviation comparison. Again, in order to interpret this, we can decrease the decimal places to 2 decimal spots. Okay, and so we get a standard deviation comparison of 2.31. Now, if you refer to the PowerPoint, again, it talks about this. If we get a standard deviation comparison of greater than 2, what does that mean? Okay, just like in this example, right? We got a standard deviation comparison of 2.31. That's greater than 2. What does that mean? Basically, what that means is that this standard deviation, our larger standard deviation, which was for the low functioning group here, this 3.16, it is greater than, or it is more than, twice as large as the standard deviation for our group 1, okay, which is our high functioning group. Okay, again, this just so happened to be the smaller standard deviation, okay, for group 1. So again, what is this saying? This standard deviation comparison is saying, because it's greater than 2, it's saying that this standard deviation is more than twice as large as this standard deviation here. Because it's more than twice as large, again, it talks about this in the PowerPoint, we can interpret the variance as being unequal. Again, this standard deviation is over twice as large as this one. And remember, standard deviation is a measure of variability. And so is the variability equal? Is the variance equal? No, it's not. Okay, it's unequal. Because this one's over twice as large as this one, the variance is unequal. Okay, in this example here, in the example that I'm working here in this video. So what's going to be my answer for question 3? My answer is going to be unequal. The variance is unequal because when we did this comparison between standard deviations, we got a value greater than 2. Now, if you get a value less than 2, what does that mean? If you get a value less than 2, that means that the standard deviation for the higher group was less than twice as large as the standard deviation, okay, of the lower group, okay, or the standard deviation, or the group that had the lower standard deviation. And so if you get a standard deviation comparison value less than 2, what does that mean? That means that the variance is equal. Yeah, one standard deviation is less than twice as large as the other. Okay, they're fairly comparable with one another. Therefore, we can assume that the variances are equal. Okay, but again, in my particular video that I'm showing here, the variance is unequal, okay, because this value here is greater than 2. Again, it could be different for your data, right? So again, make sure, okay, do the appropriate steps as I've shown you here. But if your standard deviation, again, is less than 2, then that's an indication that the variance is equal, okay, between the two groups. If it's greater than 2, it's unequal. If it's less than 2, then it's equal. Okay, so a very easy interpretation here, okay, once we've compared the standard deviations to determine if the variance is equal or unequal between the groups that we're testing. In this example, they are unequal. Okay, let's move on. Question 4. What would the null hypothesis be for the mean difference in BMI between the high and low functioning groups? Again, it talks about this in the PowerPoint. Please refer to the PowerPoint for more details. But remember, a lot of times the null hypothesis is always associated with words like not, okay, like not statistically significant. And the same thing applies here. And so again, when we're performing these comparisons between two independent samples, okay, that's what we're looking at is the difference, and in particular the mean difference. And so yeah, that's what the question asks. What would the null hypothesis be for the mean difference in BMI between these two groups? Well, we could state it like this, okay? And again, if we want to be specific for this specific question here, again, we're looking at BMI. We're comparing two groups, but in particular, we're comparing high versus low functioning groups. So to be specific, we could say something like this. We could say that the mean difference in BMI between the high and low functioning groups is not statistically significant. Okay, so yeah, the null hypothesis, okay, for this particular example here, we could write it something like this. The mean difference in BMI between the high and low function groups is not statistically significant, okay, for the null hypothesis. Now, it talks about in the PowerPoint, there's other ways in order to write the null hypothesis when we compare the mean difference between two groups. We could also say it like this. We could say that the difference, and I'll write this in parentheses, the difference between the two means, okay, the means of the two groups, the difference between the two means is 0. Okay, so that's another alternative. That's another way to write the null hypothesis when comparing the mean difference between two independent samples. We could say the difference between the two means is 0. Now you might be thinking, well, wait, Dr. Palmer, that doesn't make any sense. We just calculated the mean difference up here in question 2, and obviously our answer there is not 0, right? In this particular example here in my video, it's negative 1.15. Okay, that's different than 0. So what do you mean? What are you saying here? The null hypothesis, the difference between the two means is 0. Again, it talks about this in the PowerPoint as well. Basically what we're testing when we test the null hypothesis, and again, that's what we're doing. If you look down at the next question, question 5, this is what that question 5, that's when we're going to perform the independent samples t-test to test. Basically, we're testing the null hypothesis. Okay, when we perform this independent samples t-test, that's what we're testing. When we test the null hypothesis, we're testing if the difference that we calculate, the mean difference, is statistically significant. Another way to word that is the mean difference real? Okay, is it real or not? And so even though, yeah, our actual mean difference that we calculated up here is not 0, we still don't know if this difference is real. Okay, yeah, we don't know if it's statistically significant, and or another way to word that, we don't know if this difference is real. Okay, and is it and another way to word it is it reliably different than 0? And again, in order to answer all those questions, that's why we have to perform an independent samples t-test to do that. That's the only way in order to determine if this difference right here is statistically significant. Is it real? Is it reliably different than 0? Okay, or the alternative, okay, if it's not statistically significant, what does that mean? That means that the difference is not real. Okay, it's not reliably different from 0. This difference right here that we calculated, again, if we determine that this isn't statistically significant, that would mean that this difference right here is just by chance. Okay, by chance occurrence. By chance occurrence, we got a mean difference here of negative 1.15. Okay, if we did this exact same study again, let's pretend, okay, we did this exact same study again, we tested a different sample, let's say, of high and low functioning participants, and maybe we calculate a mean difference of negative 0.75, let's say. And then let's say we do it again. Let's say we do another study with a different sample and we calculate a mean difference of negative 1.05. Again, do you see kind of what I'm getting at here? Again, is this difference, is it reliably different from 0? Again, we could perform a study, you know, and duplicate the study 100 different times. Okay, and we get all these different mean difference values. Okay, but yeah, is this mean difference though? Is it reliably different from 0? Okay, maybe we do another study, you know, again, like I was saying earlier, maybe we do another study, another sample, and we find that the mean difference is a positive this time. Okay, maybe the high functioning group has a higher BMI than the low functioning group, and therefore we get a positive mean difference, okay, of 1.15. And so again, do you see the variability there in the mean differences that we calculate if we were to simulate this study 100 different times? Yeah, we could get different mean difference values. And so again, in order to determine if this mean difference is reliably different than 0, is it statistically significant, we've got to perform an independent samples t-test. Okay, so yeah, so again, for the null hypothesis, yes, the null hypothesis, we are basically saying that the hypothesized mean difference is 0. And again, that's what we are testing when we perform an independent samples t-test. We're testing, is that true? Is this mean difference here, okay? Is it not really reliably different than 0, or is it reliably different than 0? And again, that's how you can interpret this here. Okay, so yeah, the null hypothesis mean difference is 0, okay, when we make comparisons between two groups. and that's what we're trying to test. Okay, we're testing the mean difference that we calculate. Okay, like in question number 2, like we did earlier, is that reliably different than 0? Okay, so again, that's just another way to word it, and again, that's kind of what we're doing here in this assignment when we perform this independent samples t-test. Okay, so let's go ahead and move on. Question number 5, suppose we set the alpha level at 0.05. Perform the appropriate independent samples t-test in Excel to determine if the mean difference between the groups is statistically significant. Okay, so obviously we're going to go over here and do this in Excel. The PowerPoint, again, goes into great detail on this, so please look at and refer to the PowerPoint. But I'm going to show you here in this video, how to do it. Now, again, if you take a look up here, it says perform the appropriate independent samples t-test. And so if you look at the PowerPoint, it talks about this. In Excel, we actually have 3 different t-tests that we need to choose from. Okay, we need to determine which of those 3 is the appropriate t-test to perform in our assignment here. And so what you can do to get there is go to Excel, go to Data, go to Data Analysis, okay, and that brings up this Data Analysis window. If you scroll down towards the bottom, you'll see what I'm talking about. We've got 3 different t-tests here. Paired 2 sample for means, 2 sample assuming equal variances, and 2 sample assuming unequal variances. So the question becomes, which t-test are we going to do? Well, this first one right here, this paired 2 sample for means, again, it talks about this in the PowerPoint. This actually is not an independent samples t-test. This first one is not an independent samples t-test. This is what we call a dependent samples t-test. We'll talk more about dependent samples t-test in the next how-to video, okay, in the next PowerPoint. But FYI, this is not an independent samples t-test. So now that we have that one crossed out, right, because we know, again, we're comparing 2 independent samples, 2 independent groups. Therefore, we want to perform an independent samples t-test. Okay, again, it states that in the problem in question number 5 here. Which independent samples t-test are we going to do? Well, this first one's not an independent samples t-test. It's a dependent samples t-test. So we can go ahead and cancel that one. We know that this one's not an option for us in this particular assignment here. So now it becomes a question, which one of these 2? Which one of these 2 are we going to choose? Now, both of these 2, if you look at the PowerPoint, it states this. Both of these 2 are independent samples t-tests. Okay, both of these 2. Equal variances and unequal variances, the 2 sample assuming, these are both considered independent samples t-test. So now, of these 2 independent samples t-tests, which one is the appropriate one? Which one are we going to use in this how-to video here? Well, to determine that, just look at your answer for question number 3. Again, remember we did that standard deviation comparison earlier? Okay, and we determined based on those standard deviation comparison that the variance is unequal. So which t-test do you think we're going to use here? Which independent samples t-test should we use? If the variance is unequal, which one? It's easy, it's obvious. We're going to use this one here. So in this particular example here, in this how-to video, because my variance is unequal, okay, because we assumed up here that the variance is unequal, then we're obviously going to perform this independent samples t-test here. This t-test 2 sample assuming unequal variances, right? That makes sense. Now again, remember, your data is different, okay, so your t-tests may be different that you perform. You may perform an independent samples t-test that's equal variances, okay? All right, maybe you perform one that I'm doing here in this video. Maybe you also perform a independent samples t-test 2 sample assuming unequal variance. So again, your data is different, so therefore your independent samples t-test may be different as well. So again, just keep that in mind. But for my video here, I'm going to choose this one. Okay, assuming unequal variances. So I'm going to highlight that one, and then I'm going to click OK. Okay. Now, what I'm going to do here, and again, I've already have values already put in here from earlier, but let me erase these here. okay, and kind of get it back to, this is most likely what you would see, okay, when you pull it up, is you're not going to see anything, right? All of these are going to be blank here, okay, except for the alpha. The alpha, Excel and default, they do set it at 0.05, okay, is the alpha level. And so that may be the only thing that appears. Everything else should be blank like this. So let's start up here at the top. For variable 1 range, you can click to where your clicker is inside that box. What we're going to put here is we're going to put the BMI scores for group 1, which in this case is the higher functioning group. So what I'm going to do, once my clicker is in here, I'm going to click out here, starting with the first BMI score for the higher functioning group, and drag down all the way to the last score in the high functioning group, and then let go, and then right here it already has it for us, okay, the range of data points right here that includes all of the BMI scores for the high functioning group. Now let's go on to the variable 2 range. For variable 2 range, we're going to do the same thing but for the low functioning group, okay, for group 2. We're going to click inside here to where our clicker is inside. Then we're going to go over here and we're going to click and hold, and we're going to highlight all of the BMI scores for the low functioning group, starting with subject 11 all the way to subject 20, and then click away. Okay, what that done is it's highlighted that range, okay, that range of data points. All right, cool. Now that we've done that, we go to the next one, hypothesized mean difference. Now I just got on the big spill here about the null hypothesis, right? The null hypothesis, another way to write the null hypothesis, I stated here, the difference between the two means 0. Again, when we perform an independent samples t-test, that's what we are essentially testing. We are testing the null hypothesis. And so if we're testing the null hypothesis, and the hypothesized mean difference for the null hypothesis is what? It's going to be 0. So that's what we're going to include here for this spot. So the hypothesized mean difference, because we're testing the null hypothesis, what is it? Yeah, it's going to be 0. Labels, we don't need to do anything with that, so leave that unchecked. The alpha level, it's already set to for us by default. Remember, we set it up here in the problem. Suppose that we set the alpha level at 0.05. Remember, traditionally, that's the alpha level that is typically set by most research studies is 0.05. So yeah, we're going to leave it there. Okay, we don't need to change anything. We're going to leave the alpha level there at 0.05. Last thing, output options. Click on output range. Okay, make sure that one's selected. And then go in here and click to where your clicker is inside this box. Now go outside and go and click into an empty cell. I usually try to provide a little bit of space, okay, maybe a little bit of space, and maybe I'll even put it down here, maybe provide extra space, okay, if needed for later. I'm gonna click on this empty cell right here, okay, again, provide plenty of space in between my statistics up here, okay, and where I'm going to put my output. Basically what we're trying to figure out is where we're going to put our final output for this t-test. Where are we going to put it in the Excel sheet? And so just click on a cell that's far away from your data. That looks like a good cell right there for me. Okay, it highlights, or it recognizes that cell here. Once it's done that, you're ready to go. Okay, you've got everything filled out. Now click OK. Okay, boom. All right, so now we have our final output. That's what this is. This is our final output for our independent samples t-test that we just performed. Now if you need to, you can adjust the size of it, okay, to make it bigger or smaller. Okay, the columns, you can adjust the column size just like I'm kind of doing up here. You can do that up here at the top. Okay, but yeah, that looks pretty good. Okay, just as long as we can kind of see everything. Just as long as we can see everything, we can see what the statistics are over here and see what the values are in these columns. Okay, so now that we have our final output here, what does it say here in the problem? It says copy and paste the final output for your t-test as a picture in the space below. Make sure it's large enough for me to see. So pretty easy to do that. Just copy all of this here just like I've done. Right click, copy, and then come back over here, right click, and then you can find the paste option, or yeah, you can use the paste option as a picture, and then yeah, you can click on the picture paste option here, and then there we go. Okay, we get our output, our final output here as a picture. Okay, so that looks good. All right, so I'm gonna decrease the spaces here now so we can have it on the same page. Okay, perfect, cool. And that looks pretty big. That's big enough for me to see. So yeah, so again, if you paste it, it's real small. If you need to, yeah, you can adjust the size of it. You can go up to picture format and you can adjust the size of this. Just make sure it's large enough for me to see. And that looks pretty good. That looks pretty good right there. Definitely big enough for me to see all the variables and then, or all the statistics, and then also to all the values. Okay, so let's move on to question 6. Report the appropriate p-value. Okay, so again, it talks about this in the PowerPoint. Please refer to the PowerPoint for more details on this. Which p-value are we going to report? Notice we've got a lot of information here in our final output. We've got the means, okay, and again, you may be wondering, variable 1, variable 2, what does that mean? Really, in all honesty, the variable 1, that's representative of group 1. Variable 2 is representative of group 2, okay, that's what that means. And so group 1, and again, you can kind of check it to make sure. Group 1, what did we calculate earlier is our mean. The group 1 mean, group 1 was our higher functioning. The mean was 23.74, and lo and behold, look, yeah, it's 23.74. It's the exact same mean that we calculated earlier. So yeah, so that checks out. Same thing for group 2. Group 2 was our low functioning group. We calculated a mean of 24.89. Yeah, sure enough, it's the same mean here in the final output. So yeah, so that's another good way to check yourself. Make sure you calculated the mean correctly from earlier. Make sure it matches up with the means that you have here in your final output for your independent samples t-test. Okay, it's got other statistics here. It's got variance. Okay, remember we determined whether the variance was equal or unequal by looking at the standard deviation. Okay, so it has variance statistic here. Observations is just the sample size. Okay, so yeah, if you take a look back at our data in the Excel sheet, yeah, you'll notice that in each group, we've got 10 subjects. 10 subjects in the high functioning, 10 subjects in the low functioning. So that's what that indicates here. Sample size, 10 in the first group, 10 subjects in the second group. The hypothesized mean difference, remember we inputted that earlier. The hypothesized mean difference is 0, okay, for the null hypothesis. So that's what that is. DF, okay, DF, what is that? DF is the degrees of freedom. And we've talked about degrees of freedom before. Degrees of freedom, it's related to the sample size. The more degrees of freedom we have, the greater the statistical power, okay, of the statistical analysis that we do. And so again, yeah, refer back, I think in PowerPoint 6, I believe, it talks a little bit about degrees of freedom, okay, and so yeah, so really you don't have to concern yourself too much about the number here, the actual value here for the degrees of freedom, but yeah, just kind of just understand the concept of degrees of freedom. The higher the degrees of freedom, the more statistical power. That's really all you need to know, okay. The t-stat, the t-statistic, that is another thing that we're actually testing when we do a independent samples t-test, is we're testing this t-statistic here. You don't, again, have to concern yourself so much with the actual value here. Just that's really all you need to know, is just that when we do a t-test, we are essentially assessing the t-statistic, okay, and that's really, that's all you need to know. So yeah, we're testing the t-statistic. We're also testing the mean difference, okay, and most importantly, the mean difference. And again, talk about that quite a bit in the PowerPoint. Now, down below here, this is where this is the important stuff. This is the really important stuff here in our output when it gets here to the p-values. Now, it talks about in the PowerPoint a one-tail versus two-tail test. One-tail tests are generally frowned upon by researchers. Okay, oftentimes in research, one-tail tests are not used. And so for our class, yeah, we're not going to use it either. And so this P one-tail, this T critical one-tail, yeah, we're not going to concern ourselves with this. Okay, this is for the one-sided or one-tail test. Most research doesn't do these tests, therefore we're not going to do it in our class as well. So that brings us our attention to the last two here. Okay, we have this P two-tail and then this T critical two-tail. The T critical two-tail, again, you don't have to be too concerned about this, okay? This T critical two-tail, basically what this means is this is the critical T value that we need in order to reach statistical significance. But again, you don't really need to know that, okay? Again, it's just kind of extra information. Really, our main focus is this right here. It's this p-value right here, two-tail. This is the value that we're going to report. This is our p-value. Okay, so which p-value, which value are we going to report here to answer question 6? That's right here. This p-value two-tail, that's the p-value for a two-tailed t-test. This is the value that we're going to report. This is the value that is most often reported by researchers, okay, in studies. And so because of that, yeah, this is the value that we're going to report for our class purposes. So the p-value two-tail, what is it? Yeah, it's right over here. It says for us in question 6 to report that. We're going to round it to the first 3 decimal places. So I'm going to report that straight from this output here for two-tail. The p-value is 0.31, and then if we round it to the 3rd decimal place, if you take a look here at the 3rd decimal place here, it's a 1. If you look to the value next to it to the right, it's a 7. What does that mean we need to do here with this 1? Yeah, because it's greater than 5 over here, this 7 is greater than 5, we need to round up. We need to round this up to a 2. So then it becomes 0.312. So that's our p-value. That's our p-value. That's the appropriate p-value that we're going to report. Okay, it's this p two-tail from the output here. Okay, so in this particular example here in this video, my p-value is 0.312. Based on this p-value, should the null hypothesis be accepted or rejected? Well, based upon the p-value, again, it's greater than the alpha level, right? Remember we set the alpha level at 0.05? Okay, the alpha level was set at 0.05 here in our Excel output, on our Excel test that we did, t-test that we did. And so, yeah, our alpha level is 0.05. Our p-value is 0.312. 0.312 is greater than 0.05. Therefore, what are we going to do? Yeah, if the p-value is greater than the alpha level, okay, and in this case the alpha level is 0.05, 0.312 is greater than 0.05, we are going to accept, okay, accept or accepted. The null hypothesis should be accepted here. All right, we are going to accept the null hypothesis. Why? Because our p-value of 0.312 is greater than our alpha level of 0.05. Now again, if your p-value is less than 0.05, what are you going to do? Yeah, you're going to reject the null hypothesis. Okay, you're going to reject it if the p-value is less than 0.05. So again, your data may be different than mine. Okay, so again, just keep that in mind. Question 7. Is the mean difference between the high and low function groups statistically significant? Well, to answer this question, all we have to do is look up at the previous question, question 6. In my example, we concluded that the null hypothesis should be accepted. Okay, why? Again, I just got through talking about because the p-value is greater than 0.05. If we accept the null hypothesis, what are we stating? Well, we're accepting the null hypothesis. We're basically agreeing with it. Remember earlier we said the null hypothesis, the mean difference in BMI between the high and low function groups is not statistically significant. By accepting it, basically we're agreeing with it. We're agreeing. We're basically saying that, yeah, that's true. You know, that's correct. The mean difference between the groups is not statistically significant. So yeah, so for question 7, is the mean difference between the groups statistically significant? No, it's not. Okay, because we accepted the null hypothesis, we agree with it. Therefore, it's not statistically significant. Okay, so yeah, so based upon our answers here for question 6, that's going to dictate our answer here for question number 7. Again, it could be different for you, right? Okay, it could be the same, could be different for you for your data. Okay, so again, if you're rejecting the null, okay, if you're rejecting the null, what does that mean? That means that the mean difference is statistically significant, and so you would answer yes, okay, for question number 7 if you rejected the null hypothesis, if the p-value was less than 0.05. But again, for my data right here, for my video, okay, Again, we're accepting the null hypothesis. The p-value is greater than 0.05. Therefore, no, the mean difference is not statistically significant between the groups. Okay, let's move on. Calculate the effect size of the difference between the groups. Okay, so we need to calculate the Cohen's d effect size. Okay, remember effect size, Cohen's d, it can be abbreviated by this italicized d here. Okay, that is the effect size. So to calculate the effect size, how do we do it? Well, if you take a look back, and I'll show you here in the PowerPoint. Here you go, I'll pull it up. Yeah, here in the PowerPoint, it talks about the magnitude of the difference. And to calculate the magnitude of the difference, we're going to calculate the effect size. Okay, this Cohen's d effect size, and here's the equation here. So this is the equation right here that we're going to use to calculate the effect size to answer this question. This is the equation right here. We take the absolute value of the mean difference between the groups and we divide it by the pooled standard deviation. Okay, so I'm going to keep this right here for us. All right, for right now, so you can see that equation over here. I'm going to go to my Excel sheet now. Again, what do we have already? What do we have already to solve for the effect size? Well, we already know what the means are, right? And that's what these are. This x1, x2 with the hyphen above, these represent the sample means for group 1 and group 2. We already have the sample means. We already have the means for group 1 and group 2. We've already calculated those. So we already have that information. What do we not have in order to calculate the effect size? We don't have the pooled standard deviation. Okay, this is the one thing that we need to solve first before we can calculate the effect size. To calculate the pooled standard deviation, I'm going to add that. Okay, I'm going to add that here. I'm going to just say pooled SD. Okay, this is a new statistic. All right, the standard deviation pooled or the pooled standard deviation means the same thing. So this is a new statistic that we need to calculate. To calculate the pooled standard deviation, it's really easy. Okay, you can just click into the empty cell next to your label here for pooled standard deviation. Go to function. Go to standard deviation, okay, that we used earlier to calculate the standard deviation for the groups. And then instead of, remember earlier we did the standard deviation for each group separately to where like I only, for example, the high functioning group, I only highlighted those in the high functioning. And then when I did the standard deviation for the low functioning, I only highlighted those in the low functioning group. To get the pooled standard deviation, all you have to do is just highlight everyone in both groups combined. That's all you got to do. So that's what the pooled standard deviation is. It's the standard deviation of all the participants in both groups combined. So to do that, just left click, highlight from subject 1 all the way to the last subject, subject 20. Okay, now we've encompassed all subjects in both groups combined, and then click OK. That calculates the pooled standard deviation. Again, to better interpret it, let's decrease the decimal size, okay, to 2 decimal spots. Okay, so yeah, our pooled standard deviation in this particular example here is 2.44. All right, so now we have the data we need, okay, in order to calculate the Cohen's d effect size. So I'm going to add that again as another variable here. Again, it asks us to calculate the effect size of the difference between the groups. And again, you can italicize the D. Okay, that's the, oh, it didn't do it. You can italicize the D. That's the appropriate way to express the effect size as an italicized D symbol. And what we can do is we can actually input this formula, okay, this equation here. We can input that same equation into our cell here, into Excel, in order to solve for D, in order to solve for the effect size. So that's what I'm going to do. In order to do that, to calculate effect size, again, I'm going to punch it in just like I see it here in the equation in the PowerPoint. I'm going to start out with the empty cell highlighted. I'm going to click on my keyboard equals. Then I'm going to go up here to function. And I'm going to find the absolute value. So remember I said earlier, that's what these bars represent. Again, it talks about this in the PowerPoint. These bars here represent the absolute value. This is basically the absolute value of the mean difference between groups. So absolute value is in Excel. If you look for it, just type in absolute value. Oh, maybe, excuse me. Absolute, am I misspelling it? There we go. Okay, yeah, just type in absolute. Okay, sorry about that. Yeah, just type in absolute in order to search for the absolute value function. Type in absolute like I've done, and it's this one right here. It's ABS. It's this first one listed, and it returns the absolute value of a number. Okay, so yeah, so that's the one we want. ABS, that's the absolute value function in Excel. So highlight it and then click OK. All right, and so that selects the absolute value function. Then what we're going to do, we're actually going to go up. Let's see, let me move this down just a tad bit so you can see. We're actually going to go up here next. So notice that, again, the equation that we have written down here in our cell, it's the same equation up here in this bar. We're actually going to go to the bar next here, and I'm going to click inside the parentheses of the absolute value. So here's that absolute value function, and then you'll notice that, yeah, the parentheses are here. I'm going to click to where my clicker is now blinking inside the parentheses. Then what I'm going to do is I'm going to, again, type in just what I see here in the equation. The first one here is, again, absolute value, right? That's what the bars are, absolute value. And the first one is sample mean of group 1. In this example, our group 1 mean is right here for the high functioning group, so I'm going to click on it. Okay, so yeah, so there we go. So that highlights the cell of the mean for group 1. Then in the equation it says minus, so I'm going to hit the minus sign on my keyboard. Then it says the sample mean for group 2. So the sample mean for group 2 is right here, the mean for the low function group in this case. I'm going to click on it. Okay, that highlights the cell there and puts it there in the equation, okay, with the mean for group 2. Now I'm going to click outside the absolute value. So notice again, the absolute value is only for the means inside. Now that I have the mean 1 minus mean 2, okay, duplication over here, yeah, mean 1 minus mean 2 inside absolute value bars. Now what I'm going to do is I'm going to go and finish the rest of the equation outside of the absolute value bars. The equation says, again, this right here just indicates divided by. So I'm going to hit the divided by, the slash sign on my keyboard, divided by, okay, and then, yeah, divided by the pulled standard deviation, which is what we just calculated up here. So now I'm going to click on this cell that contains my pulled standard deviation I just calculated. Then after that, then we're ready to go. We've got everything, okay? Again, all I did is I just went through and I just basically duplicated the same equation over here in the PowerPoint in Excel. Now that I'm ready, okay, I've done it. Now I'm going to click OK. And that calculates the effect size D, okay, Cohen's D effect size for us. All right, there we go. And again, let's adjust the decimal there to round it to the first 2 decimal spots. And if we go back, yeah, to our Word document assignment here, it actually says that calculate the effect size, round it to the second decimal place. So yeah, so let's do that. And so we get an effect size of 0.47 here in this video. Again, your data is different, so your effect size may be different as well. Okay, so just keep that in mind. So effect size equals 0.47. Next question, number 9. It says the effect size calculated in question 9 indicates a, and we've got multiple choices here, okay? A trivial, a small, a moderate, or a large difference. Well, in order to figure that out, again, there's information on this in the PowerPoint. Let's take a look. If we take a look at the PowerPoint, and let's see, where is that going to be? Okay, yeah, here it is. I found it. So here's the slide right here that talks about interpreting the effect size. Okay, so once we've calculated the effect size, how do we interpret that? Okay, what does it indicate? And so, yeah, so to answer that question, okay, to answer a question, let me pull this over on this side. So to answer this question, question 9, the effect size calculated in question, oh, excuse me, yeah, I need to change this. I'll change this in your assignment. Yeah, so this is, I should have had this. So the effect size calculated in question 8. All right, sorry about that. I'll change that for your assignment so it reads like this. So yeah, the effect size that we calculated here for question 8, and again in our example was 0.47, indicates what? So for question 9, to answer this, if we look at our answer for question 8, we get an effect size of 0.47. Where does 0.47, where does it fall under here? Well, if you take a look, where does it fall under? Right under here, right? In this second one. Okay, I'll highlight it. we got an effect size of 0.47. That falls in between 0.20 and 0.49, right? Yeah, it falls within that range. So what does that indicate? That indicates a small difference. So this effect size of 0.47, that indicates a small difference, okay, between the groups in this example. So that's going to be my answer here for question 9 is small difference. And again, if your effect size, it may be different, and therefore, yeah, your interpretation here, okay, what does it indicate may be different as well, okay? It may not necessarily be, it could be a small difference, all right, for your data for your sum at 5, but it could be something else, okay? It could be one of these other choices. So again, just keep that in mind. And again, how do we solve that? We just look back at our effect size, and based upon our effect size, that's going to dictate what type of difference, okay? The magnitude of the difference, how big it is. Okay, so depending upon our answer here, that's going to dictate our answer here for question 9. Okay, last question here. Question 10, it says create a bar graph showing the mean BMI and standard deviation for the high and low functioning groups. Include labels for both the horizontal and vertical axes, and then label those axes functional ability and body mass index. Okay, so those are the first few steps there that we're going to do in creating this bar graph. To create a bar graph, it's fairly simple. And again, we're creating a bar graph of what? Yeah, it says show the mean BMI and standard deviation for both groups. So that's what we're creating a bar graph of. In order to do that, go back to Excel, go to Insert, and before we click on a chart, okay, we're going to click on the bar chart, which is the bar graph. Before we do that, we need to highlight the data that we need to show. The data that we're going to initially show are the means, and then eventually we will add the standard deviations to this graph. But the first initial graph here that we're going to create are just going to be the means. So to do that, what I want you to do, what you need to do is you need to highlight what I've highlighted here. Highlight to where you have the labels, okay, make sure and do that. Highlight the labels, high functioning, low functioning, and then also highlight the means for both groups, just like I've done. Once you've done that, yeah, then you go to Insert, then you go over to Chart, and you're going to go to this first one here, okay, Insert Column or Bar Chart. Click on it, and then it's actually this very first choice. It's this one right here, this clustered column. Click on that one, and then that creates our bar graph or bar chart. Let's see, and I'll just move it right here on top of this for right now so you can see. Okay, great. So now we've got our default bar graph created. Again, there's lots of steps. I already talked about the first few here. Again, we're going to need to create labels next. Include labels for both the horizontal and vertical axes, and we need to make those size 11 font. We're going to label the horizontal axis functional ability. So let's do that one first. So to do that, again, similar to previous graphs I've had you created, go to highlight the graph, go to chart design, go to add chart element, go to axis title, go to horizontal, and then we're going to type in, okay, what it says for us to do, functional ability, okay, for the horizontal axis there. And let's go ahead and bold it, okay, just like it is here. And again, remember, it also says size 11 font for these axes labels. So let's change that as well. To change the font, you can go up here. Notice it's size 10 font right now. Let's click on it and let's change it to size 11. Size 11, it makes it a little bit bigger, a little bit easier to see. That looks good. Okay, and if we need to, also we can make this black. Okay, again, to make it a little bit easier to see, so you can change the font color to black, and that just, again, just makes it a little bit easier for us to see. Makes it a little bit more clear. We're going to also create a vertical axis. So again, have the chart highlighted, go to chart design, add chart element, go to axis title, go to vertical. And then we're going to change that name to body mass index. And let's also include, like it says there, the units, kgm, and then squared. You can just put in a number 2 for right now, and I'll show you real quick. In order to make this, notice that this is a superscript, right? Okay, BMI, it's meters squared, okay, exponent, superscript. In order to make this a superscript, highlight it, okay, highlight the 2, go up to home, go to font, click on this here, and then go over here to superscript, and then click on it where there's a check there, and then click OK. And then, yeah, then that puts it as an exponent there for you. All right, so that looks good. Again, same thing, we need to bold it. Okay, we can make it black. And then also we need to increase the font size, okay, for the labels, both labels. We already did that for the horizontal. Let's do it for the vertical. Let's change that to 11. Make it a little bit bigger, easier to see. All right, that looks good. Okay, moving on. Remove the title and delete all grid lines. Okay, so I'm going to remove the title. Just click on the title here and then click delete on your keyboard. That deletes it. Delete the grid lines. Okay, looks like all we have are horizontal grid lines here for this bar graph. Click on them, highlight them, and then hit delete on your keyboard. That should delete them. And then, yeah, except for the axes. And then it also says here in parentheses, add a gray vertical or horizontal axis if needed. Well, we already have a horizontal axis. Do you see that? Let's see, let me click away. Yeah, we already have a horizontal axis line here. Okay, but do we have a vertical axis? Yeah, you'll actually notice that the default here, at least on my computer, now it might be slightly different for yours, but the default for mine when creating a bar graph, it actually leaves out the vertical axis. So yeah, crazy. I don't know why it does that, but it's really easy. So again, like the instructions say, we need to add a gray vertical or horizontal axis if needed. We already have the horizontal axis, but let's add the vertical axis to this. We need to do that. So to do that, you can just click on the vertical values here, and then once they're highlighted, right click, go to Format Axis, go to Paint Bucket, go to Line, go to Solid Line, and then go to Gray. And the gray one you can choose. This one, I think it matches up with the horizontal one that's already there by default, so you can click on that one. Again, it's this one right here. You can go to, and then yeah, if you look back now we have this vertical axes created, which looks similar in color to the gray axes for the horizontal. That looks good. All right, cool. Insert major tick marks on the outside of both axes. So to do that, remember from earlier videos, we've done this before. Let's do the horizontal first. Highlight the horizontal, right click, Format Axis, Axis Options, Tick Marks, go to Major Type, go to Outside. Okay, that adds the tick mark right here. Same thing, vertical, highlight, right click, Format Axis, Axis Options, Tick Marks, Major Type, Outside. Okay, and that adds those tick marks there for each value. Okay, that looks good. Have the high functioning bar colored black. Okay, so you'll notice that the bars, the actual bars here, which represent the means, okay, they represent the means. And again, how do you know that? Well, you can kind of check and see, but for the high functioning, remember the mean was 23.74. Look at the top of the bar and then scroll over to the vertical. Yeah, that's at about 23.74. So that looks appropriate. That looks correct. Same thing for the low functioning. Low functioning was 24.89. If we go to the top of the bar and then scroll over to the vertical, yeah, that's correct, right? It's in between these two at about 24.89. So that looks right. And so again, that's another way to check yourself. Make sure that the bar graph is correctly demonstrating the means. You can do what I did and check and kind of eyeball and make sure that that looks appropriate. That looks correct. Okay, so high functioning bar, okay, which represents the mean for the high functioning group. In order to do that, click on the bars, okay, notice it highlights the entire graph, but then it also highlights the bars too. And then click again specifically on the higher functioning. That should now, okay, once you click again on just the higher functioning, that should just highlight the higher function, and it does. Do you see that? See how this bar is the only one that's highlighted? The low function is no longer highlighted. It's just the higher functioning. And it says in the instructions, that we need to have the higher functioning bar colored black. So now that this is highlighted, just this one, right click, format data point, go to paint bucket, go to fill, go to solid fill, and then go to black, and that changes it to black. Also too, if you look ahead, it says at the very end of the sentence, no outline or border. So to once we have it highlighted, once we've changed it to black fill, go to border, which is right down below, and then just go to no line. Okay, and that removes any border or outline, okay, around the bar. All right, so that looks good. It says for the next one, have the low functioning bar colored gray. Okay, so we need to do this now. So again, click on your graph. Once you click on the low functioning bar the first time, it'll highlight the graph, it'll highlight both bars, right? Do you see that? Then click on the low functioning bar again, just the low functioning a second time. Now that highlights just the low functioning bar. See how it's not highlighted the high functioning anymore? This is no longer highlighted. Now it's just this one, the one that we want to change, the low functioning bar. Now that this one is only highlighted, right click, format data point, go to paint bucket, go to fill, solid fill, go to color, and then let's change this to a gray. Now a good gray that I've found with when I've made graphs for research studies is this one right here, kind of towards the bottom. I've used that one, and that one works pretty good. It's pretty easy to see, so we can select that one as well. Again, just like with the other one, it says no outline or border. So once we've changed it to gray, the fill, let's go to border and let's click no line. And that removes the border from that bar. Cool, that looks great. Include SD arrow bars, okay? Standard error bars plus direction only with caps. So this is where the standard deviation comes into play. So to add standard deviations to the graph, standard deviations are going to be represented by the error bars. So how do we do this? If we click on the graph and highlight it, okay, just like I've done here, go to chart design, go to add chart element, go to error bars, and then scroll all the way down to error bar options. Okay, I know it's tempting. You might say, well, wait, Dr. Palmer, there's a standard deviation right here. Why not click on this? Again, just trust me. Okay, trust me here. Go to this one. Okay, go to more error bar options and then click on that one. You'll notice that that does add error bars. Okay, they're highlighted here. Again, click on one of them. Okay, to where they're both highlighted like this is. Right click and then go to format error bars. Okay, so once the error bars are highlighted, right click and then go to format arrow bars. It says in the instructions plus direction only with caps. So what does that mean? Well, if you look here, the first thing is direction. Okay, so yeah, so under this direction, go to plus. Okay, why? Because it tells us to, plus direction only. So for direction, hit plus. What does that mean? That just means the arrow bars are just in the plus direction only. Notice originally the default was both. Notice how the arrow bars goes up, but they also go down too inside the bar. We don't want that. We just want the plus. So just hit the plus, and now the arrow bars are just going up. Okay, they're not going down. Okay, inside the bar, they're just going up. That looks good. It also says with a cap. So if you look at the in style, there's selections for no cap and cap. The default is cap. Okay, so make sure that's selected cap. All the cap is, do you see the little top here? Do you see that little horizontal line at the top? That's the cap. Okay, so yeah, we want that. We want those caps, and so you can keep that there selected. Okay, yes, we want the caps. Now, the tricky part here, okay, probably the trickiest part with adding the standard deviations is this next part here. What you need to do is you need to go down to this error amounts, and you need to go down to custom. Okay, and again, you might be saying, well, wait, Dr. Palmer, there's a standard deviation. Isn't that what we're doing? Yes, we are. Okay, but again, just trust me. Just trust me here. Okay, when we're doing these standard deviations, this is what we want to do. So go to arrow amount and then go to custom. Okay, and then next what we're going to do is we're going to go to specify value. And then that brings up this window here. Next, what you're going to do is you're going to delete this in the positive error value to where it's blank and only your clicker is clicking here. Then you're going to go back to your spreadsheet, and you're going to, and make sure and do this in exactly the way I'm showing you. You're going to left click and highlight the first standard deviation of the first group, which in this case is the higher function. You're going to click and highlight this cell with that first standard deviation, and you're going to click and hold, and you're going to drag to the second cell. The second cell has the standard deviation for the other group, the second group, the low functioning group. And then let go, and that should highlight both standard deviations. Next, click and highlight and delete the negative error value to where there's nothing in there except for your clicker, which is blinking. And then do the same thing that you just did up above for the positive value. Left click, hold, drag to where both standard deviations for both groups are highlighted. Then click OK. All right. Now what that's done is that set the appropriate standard deviations, the standard deviations that we calculated earlier above. Again, in order to check yourself, okay, you can take a look. You can take a look at the magnitude, the size of the standard deviations. And yeah, it's pretty obvious in this one, okay, that yeah, one standard deviation is much larger than the other. And remember, that was how we determined whether there was equal variance between the groups. In this case, in this example, there was unequal variance. Why? Well, primarily it has to do, and we determined this, it has to do with the standard deviation and how much larger this standard deviation is than the other. You can see that in the graph. Do you see for the lower functioning group, see how much higher the standard deviation is than the other? Do you see how much longer? See how long this arrow bar is? This arrow bar again indicates the standard deviation. See how much bigger, how much longer this arrow bar is compared to this arrow bar? And so yeah, so you can easily see that yeah, this arrow bar is over twice as long, right? And we determined that up here when we did this SD comparison. But yeah, we can see it in the graph too, that this arrow bar, this standard deviation is over twice as large than this standard deviation over here. And so yeah, we can see that it's representing this in the graph. And so again, this is another benefit of creating a graph. Not only do we have the means reported, okay, as values here, sometimes it's nice to actually see a visual description, okay, of what we're reporting, and a bar graph is a great way to do that. A great way to do that. Okay, now we've added these standard deviation error bars. Let's move on. For the horizontal axis, make the high functioning, low functioning text black. Okay, so what does that mean? Yeah, it's talking about this here. So again, we have our bars, right? And again, they have the text underneath each appropriate bar. So this bar right here is the high functioning bar. This is the low functioning bar for the low functioning group. Highlight these, highlight this to where it's highlighted like this. And then it says make the text black. Okay, so to do that, go to the home. Once when it's highlighted, okay, when it's highlighted, go to home, and then go to the font here. Okay, and then yeah, you can click on the black text. Okay, or this one here, again, black, and it just again makes it a little bit more defined, a little bit easier to see the text here. It also says make it size 10 font. So again, when it's highlighted, go up here, you'll notice it's at 9 font, the default. You need to change that to 10. Okay, so you can just go up here and increase the font size to 10, makes it a little bit larger, a little bit easier to see. That looks good. Okay, for the vertical axis, make the minimum bound value 20 and the maximum bound value 28. Okay, so if we take a look over here, we can highlight the vertical axis, right click, format axis, go to axis options. This is where we're going to change the bounds. It says the minimum bound value needs to be 20. So let's change that to 20. Okay, that looks good. All right, and then again, remember my data is different than yours. And so I'm actually going to keep this maximum where it is at 29. Again, notice in the instructions it says maximum bound value 28. I don't want to do that because if I do, then that could potentially cut this off, and I don't want it to cut it off from my graph. I want to be able to see everything in my graph in its entirety. And so For my graph, for my data in this video, I'm going to keep the maximum bound value at 29. However, for your graph, for your assignment, again, these guidelines here in question 10 are for your assignment. Okay, make sure and follow these instructions exactly the way they are, because these are built, these are specifically for your assignment 5 for your data. So again, remember, one of the things that I grade you on for your assignments is how well you can follow instructions. Okay, not only are you getting the correct answers, all right, for all the previous questions we've done, but also too, for a question like this, are you following all the instructions exactly the way I have them here? So make sure when you're doing your assignment 5, you follow all of these instructions exactly the way I have them. However, for mine, okay, because my data is different than yours, I'm going to leave this maximum bound value at 29, okay, instead of 28. Okay, now it says with major units of 1, all right, looks like my major units are already preset here at 1. We don't need to change that. Again, if you do need to change it, all right, make sure and do so. Change it to a major unit of 1 to where there's 1, right, in between each successive value. 0 decimal places. Okay, we need to make these 0 decimal places. Notice how, look, this default, at least for mine, it might be different for yours, but the default for mine has 2 decimal places, right? There's 2 spots to the right of the decimal. So we need to change that. So to do that, highlight just like we have here, right click, format access, access options here, go down to number, and then select the category number. Okay, it's already selected here for me. Go to decimal places and then change that from 2 to 0. Okay, why? Because it tells us to, 0 decimal places. And then you can click away and then notice that, yeah, now the decimal places are removed, okay, to where there's 0 decimal places here for the numbers. Okay, it's just the whole numbers, right? Now we all we see are just the whole numbers. There's no decimal places to the right of the decimal. Okay, that looks good. And then black text with size 10 font. Okay, so again, highlight this here, okay, to where your numbers are highlighted in the vertical. Go up here to font color, okay, click on it, change it to black font. All right, easier to see now. And then increase the size font, it says to 10. So again, you can change the font while it's highlighted down there in your graph to 10. Just makes it a little bit bigger, a little bit larger, easier to see. That looks good. Okay, it says include an asterisk over the center of the low functioning bar above the SD arrow bar if the difference between the groups was statistically significant. Now, in my example here, did I find a statistical significance between these two groups? Again, if you go back to that question 7, it asked that, is the mean difference between the two groups statistically significant? Again, remember my answer was no, right? It was no because my p-value was greater than 0.05. Okay, we accepted the null hypothesis because of that, and by accepting the null, yeah, basically we're saying that the mean difference is not statistically significant. So in my example here, okay, the difference between these groups is not statistically significant. And so it says here in the instructions include an asterisk only if the difference between the groups was statistically significant. So for my graph, I'm actually not going to include an asterisk. I'm not going to include an asterisk over mine because there's no significant difference between the groups. That's what that asterisk indicates. And in most research articles and most research studies, they use asterisks in graphs in order to indicate significant difference. And so because I didn't have a significant difference, okay, based upon my results, I'm not going to include an asterisk here in my graph. However, again, just in case, let's just say in your data, now again, you might have the similar data to mine where there's not a significant difference, and therefore you're not going to put an asterisk in yours, just like I'm doing in mine. But just in case your data, okay, does show a statistically significant difference, okay, just in case your data does, and we need to put an asterisk, okay, in your graph, I'm going to show you how to do that real quick. Highlight the graph, go to Insert, while the graph's highlighted, go to Text, go to Text Box, add a text box, okay, it doesn't have to be very big, something like this. And then once you add it, and you'll notice that my cursor is blinking inside the text box. You can click on your keyboard Shift and hold Shift down, and then click on the number 8. And that should, when you hold Shift down and then click 8, that should add an asterisk. And you see that there. Okay, so that adds an asterisk inside my text box. That looks good. Also too, notice include an asterisk size 14 font. So yeah, if you have to add an asterisk, all right, to indicate a significant difference in your graph or your data in your assignment 5, if, okay, I don't know, again, that's your job, right? Okay, is to answer the questions to determine if you have a statistically significant difference. If you determine, okay, answering the questions that you have a statistically significant difference between the groups, then yeah, you need to do this. You need to add this asterisk here, and then you need to change it to, according to the instructions, size 14 font. So to do that, have the text box highlighted just like I have, go up to the top, and then you can increase the size of the font. You can do it here, or you can just simply click up, okay, and that increases the font size and increase it to size 14. Just makes it a little bit bigger, a little bit larger, easier to see. Okay. Make sure the text box is large enough, okay, to see the asterisk in its entirety. And then it says to position the asterisk over the low functioning group. Okay, so the low functioning group is this bar right here. Okay, so you could, again, if you have to do this, you could position it just like I'm doing here. Okay, something like this. And sometimes it's easier, especially when dealing with small things like this, like the asterisk here, is to zoom in. So I can zoom in here for you and you can see, there we go. Sometimes it's easier to zoom in like I'm doing, okay, when making these little small corrections, okay, in your graph. And so yeah, you can zoom in like I've done, okay, in order to do that, in order to put the asterisk directly over that error bar, that standard deviation error bar, directly over the center of it, okay, where there's a little bit of space in between the error bar, okay, and the asterisk. So something like that there, that looks good. Okay, so again, if you, okay, determine in your assignment that you do have a significant difference between the groups, then yeah, you'll need to add an asterisk in order to indicate that in the graph. And so yeah, you can do something like I just showed you there. However, again, in my example and my data, I don't have a significant difference, a statistically significant difference between the two groups, so I don't need to do this, so I'm going to delete it, okay, because I didn't find a significant difference between my groups, so I don't need to show that, okay, in my graph. Okay, I don't need to show an asterisk in my graph because I didn't find a significant difference between my groups. Okay, let's move on. Insert gray break lines for the vertical axis and cover in white the 2 and 20 so that the origin, the starting value on the vertical axis, is 0. So something similar to what we did in the previous how-to video with correlation. With our graph, we're going to do the same thing here with our bar graph. We are going to insert break lines. Remember, we insert break lines in order to indicate a gap in the data, in the values. And so in just a second, what we're going to do is we're going to cover this 2 up to where the starting point, the origin, is 0. If the starting point is 0 and then the very first value is 21 and then it goes up by 22, 23 by 1, okay, with each successive value, obviously there's a huge gap here, right, in the values. We jump up from 0 to 21, okay, and in order to indicate that jump in the data, that's why we put the break lines. That's why we put the break lines right here in between, okay, the 0, the origin, and the first data point on the axis. In order to do that, just like we did last time, you can click and highlight your graph, then go up to Insert, go up to Illustrations, go up to Shapes, and then go up to Line, okay, find line in the shapes, and then you can actually create a line that's slanted like I'm doing here, okay, it doesn't have to be very long, something like this. And then once it's highlighted, once you've created it, you can go to right-click, Format Object. Notice in the instructions it says Insert Gray break line, so we need to change this to gray. To do that, right-click, Format, go to Solid Line, and then go to Color, and then change this to gray. And again, you can use really any gray, but this gray right here tends to work pretty well, so you could use that one right there for your gray break line, and then that should change the line to gray. Once it's clicked like this, you can copy and paste this to make a duplicate. So remember, when we create break lines, yeah, we need to have 2 of them, okay, for each axis. And in this case, with the bar graph, notice that the horizontal axis doesn't have any values. So in this case with our bar graph, the horizontal axis doesn't have any values, so we don't need to put break lines for this, obviously, because it doesn't have any values. But for the vertical axis, we do have values, and because we're making this jump from the origin, okay, to this first data point here, that's why we need to add these vertical break lines. Again, you can zoom in even more so than I have. So really, yeah, when you're dealing with these super small lines, you can do this just like I'm doing. Zoom in, and then you can place them strategically. Yeah, maybe somewhere about right there. Again, in between, on the axis, in between the origin and the first data point. Okay, so something like that there, that looks pretty good. Now that we've inserted gray break lines, it says cover in white the 2 and 20 so that the origin is 0. Okay, so here's our 20. We need to cover in white so that the origin is 0. So yeah, so this is a little trick I showed you last week. We're going to do it again. So again, make sure that the graph is highlighted, okay, where the border is highlighted. Go to Insert, go to Text Box, go to Text Box here, and then create a text box. Again, it doesn't have to be very big, just big enough to cover that 2. Once you've created your text box, click on the border to where it's highlighted like this. Right click on the border, go to Format Object, go to Fill, go to Solid Fill, and then go to White, okay, to where it's white inside. Make sure there's no border, there's no line on this, okay, so make sure, yeah, when you're creating your text box right here, make sure there's no line, okay. Once you've done that, you can click and drag it, okay, left click, drag it, and then position it over that 2 to where it's completely covered. And then yeah, that looks great right there. So now it looks like the starting point is where we want it, okay, at 0. And then yeah, we have the breakpoints to indicate a jump in the data from 0 to 21, and then 22, 23, and so on as it shows in the graph. Okay, that looks good. All right, and then once finished, copy and paste your bar graph as a picture in the space below. Okay, so I'm going to zoom out to where now I can see my graph in its entirety, and yeah, look how we're zooming out, and notice that now there is a little, I was seeing my 2 there, yeah, that I had just covered up earlier. So you might notice that too, that sometimes when you zoom in and zoom out, sometimes, you know, things shift slightly, and so you may have to make slight adjustments just like I did. But yeah, make sure that that 2 is covered up in its entirety to where we can't see it. Okay, yeah, that looks really good right there. So now that we have our graph, again, we can either copy it, okay, and paste it directly in here, or we can use that snipping tool. I'm going to use that snipping tool real quick. Let's see if I can get it to work here. Okay, got that. That looks good. Got everything snipped, and then go to copy. All right, that looks good. And then you can minimize that, and then now you should be ready to paste. Hit paste. Okay, and then yeah, if you need to adjust the size, maybe make it a little bit smaller so that it kind of fits on this page. That's what I'm going to do, just a tad bit smaller. There we go. Yeah, I knew I didn't have to make it too much smaller. So yeah, so definitely, you know, make it large, still make it large enough for me to see. Okay, but yeah, if you need to make maybe a slight adjustment, smaller or larger, in order for it to fit on the page, then yeah, then please do so. Yeah, that looks really good right there. All right, so yeah, we made our nice bar graph there. That looks excellent. Again, what does this showcase? Yeah, this showcases the means represented by the bars and the standard deviations represented by the error bars. And so this is a visual description, okay, of what we did earlier. A visual description of the means and standard deviations. Now again, you might say, well, gosh, it looks like there's a difference there. And again, we did find a mean difference, right? We did find a mean difference, okay, between these two groups. However, the question, okay, and again, when we use statistics and we use analyses like we did today, we're using an independent samples t-test analysis. And in order to determine the difference, okay, between the groups, what we're trying to determine is if that mean difference is statistically significant. So again, yeah, obviously there's a difference, but is that mean difference statistically significant? Is it real? Is it reliably different from zero? And if you remember in our how-to video, in this example, in the data that I worked today, we found no statistically significant difference, okay, for the mean difference between the groups. And again, your data may be different than mine. You might, in your data, you might have a statistically significant difference between the groups. And again, remember, if that's the case, if you do have a statistically significant difference between the groups, make sure and indicate that in your graph by including an asterisk. In this case specifically over the low functioning bar. All right, wow, yeah, that looks great. And so again, I think that's it. I think that's all the questions. And so yeah, so once you've answered all the questions, for your assignment 5, okay, make sure and save it to your computer, okay, with all of your answers, assignment 5. And then once you've saved your assignment 5 with all of your answers, then you can go back to Blackboard and you can upload it on the appropriate Dropbox for the assignment. Okay, I think that was it. Again, I know this video was fairly long, okay, kind of similar to last how-to video, but again, a lot of these questions that we were working today were multi-part questions, right? And so again, it does take a little bit more time in order to answer those, and so that's why it took us a little bit more time today as opposed to some of those earlier how-to videos that we did earlier in the course. Okay, I think that's it. Hopefully this video is helpful. You obviously use this video in order to help you in answering your questions for your assignment 5 with your data. Hope you have a great day. We'll see you next time. Bye-bye.